Correct answers do not guarantee consistent behavior. A reliable multi-agent system should remain stable across equivalent runs, without drifting into redundant work or loops. I'm Mehrdad. Let's measure behavioral consistency without treating every valid variation as a failure. One pair of runs cannot define consistency. Reliability is the distribution we see when equivalent requests repeat across paraphrases, seeds, and operating conditions. That distribution includes success, path shape, speed, retries, and the range of acceptable variation. The method is simple. Repeat the task, compare structure, measure progress, then detect cycles. We are not demanding identical pros or one frozen path. We are asking whether successful behavior stays inside an acceptable operating envelope, and whether rare deviations carry meaningful risk. Our reference path uses 6 cooperating components, beginning when the orchestrator classifies and delegates the request. The account agent resolves identity, and the order agent finds the duplicate transaction. The policy agent checks eligibility before the payment agent issues one idempotent refund. The communication agent sends confirmation only after that right succeeds. A valid path may combine steps or add a justified check, but those dependencies remain. We do not require one exact sequence when several paths preserve the same preconditions. This gives us observable progress. Identity resolved, duplicate found, eligibility established, refund submitted, and confirmation sent. Each checkpoint should come from durable tool state, not an agent merely claiming completion. If this mechanism first evaluation is useful, like the video and subscribe for the rest of the multi-agent evaluation series. Now vary the wording without changing the task. A customer might say charged twice, duplicate payment, or 2 debits for 1 order. Fact order can change too. The identity, duplicate transaction, requested refund, and confirmation requirement cannot. Those requests form one task family only after semantic checks confirm the same intent and constraints. Run several paraphrases and seeds, then report single run success beside pass to the K, whether every one of K independent trials succeeds. As K grows, this becomes a stricter reliability question, not another average score. Slice the result by task family rather than hiding a fragile refund path inside easier requests. TauBench established this outcome-level idea in simulated customer service settings. It does not measure multi-agent handoff quality. The safe production lesson is narrower. A strong average can hide weak repeatability. Compare runs in layers, starting with whether every outcome invariant held and which agents and tools participated. Then ask whether dependencies and handoffs stayed in a valid order. Check consequential arguments separately, followed by steps, latency, retries, and replans. Different wording and harmless tool argument formatting are not automatically drift. Structural changes usually deserve more attention. A missing policy check, payment before eligibility, or a new handoff that changes authority. Arguments still matter when they carry an amount, account identifier, date, approval flag, or right parameter. Where valid procedures can be specified, full path checks can allow several accepted routes while rejecting skipped preconditions and harmful calls. Emerging controlled studies of tool using single agents support separating composition, order, and arguments. They do not prove that the same thresholds transfer unchanged to multi-agent workflows. After enough runs, the paths form a behavioral fingerprint. Count transitions between agents, common tool sequences, path lengths, retry rates, replans, and the first point where trajectories diverge. Compare variation within one release before comparing releases. Preserve traffic mix, tool availability, and policy regime, or the comparison confounds system drift with changed conditions. Suppose both versions still refund correctly, but the new release sends far more cases from order to policy, back to order, then through policy again. That shifted fingerprint is a review signal. It is not automatic proof of degradation. An anomaly exists relative to a task family baseline, confidence threshold, and operating condition. Procedural fingerprints have direct evidence in coding agent research. Using them across multi-agent handoffs is a reasonable engineering extension that still requires local validation. The refund now reaches eligibility, but payment returns a permanent policy rejection. One physical cycle can cross 4 surfaces as the planner regenerates the same impossible plan. A tool wrapper can repeat the rejected call, while replanning restates the goal without changing constraints. Orchestration can alternate between policy and payment agents, with each handoff appearing locally reasonable. Local logs may show valid requests and valid responses, while the global workflow remains stuck. These are connected surfaces carrying one unresolved cycle through the system, not four disconnected loop types. Emerging static analysis also warns about feedback paths that can invoke models, tools, or agents without an effective bound. Runtime traces tell us whether that architectural risk became actual no-progress behavior and where the bound failed to cover the path. Repetition alone is not enough. A suspicious loop begins when a contiguous action cycle repeats, while the relevant state stays the same or changes negligibly. No new evidence justifies another pass, and repetition exceeds the task-specific allowance. Build the state digest from observable invariants, not the entire conversation. For this refund, track whether identity is resolved, the duplicate is identified, eligibility is established, the refund has a transaction identifier, and confirmation is sent. A policy recheck after new evidence advances state. Policy to payment to policy with the same permanent rejection does not. Count actions inside repeated no-progress cycles as redundant, then normalize by total actions when a ratio helps compare runs of different lengths. The ratio is diagnostic context, not a universal pass line. Tide formalizes a related state cycle view and measures redundant actions with loop ratio. State equality is easier in structured environments than natural language workflows, so define tolerance explicitly. Near-identical states count as unchanged only when the difference cannot affect the next decision. Now the payment service returns a 429 rate limit error before any refund is created. Waiting, preserving the item potency key, and retrying once can be legitimate. The error is transient. Policy permits the retry, backoff changes the operating condition, and a hardbound terminates the path. The next result either creates one transaction identifier or routes the case to review. Contrast that with repeating the same refund right after an ambiguous response, using identical parameters and no item potency protection. That can create duplicate financial action even if the trace looks like recovery. Exempt retries only when error classification, backoff, item potency, bounds, and a justified change all pass. Polling, pagination, critique revision, and replanning can also repeat safely when they have measurable progress and effective limits. Put the pieces into one detector. First, define a task family from intent, required outcome, hard constraints, policy regime, available agents, and relevant operating conditions. Second, capture structured traces, agent and version, operation, tool, critical arguments, result class, state digest, plan version, handoff target, cost, latency, retries, and replans. Emerging OpenTelemetry conventions already separate planning, workflow, agent, and tool operations, although they do not define evaluation thresholds. Third, establish repeated run baselines for outcomes, paths, efficiency, and divergence. Fourth, compare successful trajectories, validating critical right arguments rather than relying on text similarity. Fifth, scan contiguous cycles and require unchanged state beyond tolerance before applying retry exemptions. Keep raw traces addressable so an alert can be explained and reproduced. Set sample sizes and thresholds from observed variance, consequence, traffic, and evaluation cost. Re-estimate them when agents, tools, prompts, policies, or workload mix change. There is no universal number of runs, global anomaly boundary, or state digest schema that fits every task family. Not every signal deserves a block, so match the response to consequence and confidence. Block a harmful call, violate a dependency, duplicate write without idempotency, or costly cycle with no effective bound. Review repeated no-progress cycles or large structural divergences, and trend persistent shifts in fingerprints, steps, tokens, or latency. Observe wording and non-critical formatting changes when function remains stable. In our case, the extra policy handoffs trigger review. The shifted release fingerprint triggers a trend alert, and a second unprotected refund write is blocked. Record which rule fired, the baseline used, and the trace evidence supporting it. Escalation follows consequence and evidence, not metric disagreement alone. Evaluate outcomes across repeated runs, and compare structure before wording. Call repetition a loop only when progress stops beyond tolerance. and preserve bounded recovery when it is justified. Do not evaluate only what the system eventually says. Evaluate what it repeatedly does and where it diverges. Then ask whether each repeated cycle creates progress. If this video was useful, subscribe to Multi-Agent Academy and connect with me on LinkedIn. I'll keep publishing evidence-backed work on agentic systems. We have measured what the system repeatedly does. In video 3, we will trace failure back through the handoffs, because the agent that turns red may not be the cause. I'll see you in the next one.